Hello, college algebra student. This video is for 5.6 rational functions. What is a rational functions? How can we recognize it? So if you have a function in a form like the one that we have here, where we have a function like a fraction of two polynomials. So remember, these are polynomials. That means they're x squared, blah, blah, blah. So if you do have two of these dividing each other, we call this a rational function, following the fact that a fraction in mathematics is called a rational number. So there are a few things that we need to know. The first thing is domain of a rational function. Domain means what can you plug in to get a f of x. So we know that in numbers, you cannot divide by 0. Right, so like 2 over 0 is not a defined number. Negative 5 over 0 is not good. You cannot do a number divided by 0. So you want to exclude all the x that would make the denominator 0. So the first thing we should know is, if I am to use a rational function, I should not plug in anything that makes the answer to have a 0 in the denominator. So for domain of a rational functions would be all numbers except numbers where it is a 0 in a denominator. And so to find a domain of a rational function, usually what we do would be we would just look at the denominator and solve it equal to 0. So like in this case, x is equal to negative 7, but we do not want it. So we would say that this has to be excluded. Right? We would exclude the zeros of the denominator and write it in an interval notation. So if I draw a number line, I have every single x that can be plugged in, but except for negative 7, I do not want it. So I would put a open circle here. All these are the x that is available in the domain. And I'll write it in interval notation. It would become negative infinity in the first section up to negative 7. Do not include negative 7, so I use the open circle, open parenthesis, and then union. Again, use the parenthesis, negative 7 up to infinity. That means anything that is exact negative 7, and this is called the interval notation. Okay, so very easy to do. You just look at the denominator, you say, I want to avoid getting this equal to 0. So I write an equation to solve. Whenever they say find domain. So you solve x squared minus 1 equal to 0. Just investigate what would make this 0. To solve this, I take factor x minus 1, x plus 1, right? So x, this equal to 0, that means x equal to 1 and x equal to negative 1. You can also do square root. In either case, if I want to write a domain, I would say negative 1 are being excluded. All the other numbers are in the domain. So to write the interval notation, it will be three sections. First is from negative infinity to negative 1. And then I want the middle section, which is negative 1 to 1. And then the last section, union 1, infinity. So that is the interval notation of domain. The last one is also very similar, a rational function. So I have the same x squared minus 1. So what is the domain? Then I would just solve it, right? X squared minus 1 equal to 0. Again, x, if I want to do square root method, I would do it this way. And then we'll say x is equal to plus and minus square root 1. Remember to do plus and minus. Now you might say, Ms. Chan, you forget that if I factor it, I can cancel x minus 1. Or x plus 1 because there's an x plus 1 in the top. Should I cancel it and say I can actually allow x plus 1? The answer is no. Even though you can cancel it, you do not cancel when you do domain. Okay, so in treating rational function, when we find domain, we do not cancel. We just take everything that is in the denominator, solve it equal to 0. So the answer is, so look, don't cancel. So there are cases where we cancel, and we'll talk about that. Okay. When we graph, we cancel it, but this is not in the domain. So again, I would use the same answer that we have earlier. So you should factor it, top and bottom, and notice that you can cancel, but when you find domain, you don't cancel. So it's still negative infinity, negative 1, union from negative 1 to 1, union from 1 to infinity. So that's domain. Let's look at our toolkit function. There's two toolkit functions that are rational function. 1 over x, because 1 is actually a polynomial, x is a polynomial. 1 over x squares, both are polynomial. Let's look at how the graph look like. Do you still remember 1 over x? The graphs are like this, 2 branches. And actually, other than 2 branches, we have actually 2 vertical and horizontal line that surface. And then some people say, okay, so this is the center of the 2 horizontal vertical line. We call this the horizontal asymptote and the vertical asymptote. Okay. So what are asymptotes? Asymptotes are lines where the graph get close to but never touch it. So it is a number that it's like the guy of the two branches, vertical or horizontal asymptote. And what about 1 over x squared? 1 over x squared is this one where it goes to the top. Both of them, right? So you see the common things. So we have a vertical asymptote also. Vertical asymptote. Horizontal asymptote is the x-axis. So you can see for most, I would say, there are some rational functions that do not have vertical asymptote. There are some vertical functions that don't have horizontal asymptote, but most of them, the one that we deal with, had vertical as well as horizontal asymptote. So that's some of the features. And also for points around the vertical asymptote, when it is getting close to the vertical asymptote, most of them, I say most of them, not all, well, actually, if it is a vertical asymptote, they either shoot up without bound or shoot down without bound. So they either shoot up to infinity or shoot down to negative infinity. So this is the features of a rational function. And in the next video, we're going to talk about how to sketch a rational function and also other features of a rational function.